Birgitta. The next speaker is Anna Silva, and she will talk about downstream migration and using turbulent eddies to be able to guide the fish downstream.
Okay, yeah. Can you hear me?
And Anna is from Nina here in Norway. So welcome, Anna.
Thank you very much. Can you hear me? Yeah, perfect. Thank you very much for the introduction. So my name is Anna Silva, and I'm a senior researcher at the Norwegian Institute for Nature Research, well known as Nina, and I'm based here in Trondheim. And today I'm going to talk about our project, the Fishpath Project, that the main scope is using turbulent eddies to guide fish. So during this conference, we've been hearing a lot about sustainable hydropower, about how important it is that we protect biodiversity in our rivers, how much do we need to create and continue developing and new designs, etc., of like fish passage to be one of the tools to help at mitigating the impacts of river fragmentation in our rivers. And fish passage or fishways, they are not new tools. They were the first designs appeared in the beginning of the 18th century, and since then we've been developing several studies to try to improve the design and to make it to be more suitable to different species. And later on, we start working a little bit on this idea of guiding systems. And yesterday, in the session of connectivity, we also had some people presenting some of the studies in connectivity. In fish guidance systems. You can have what we call the mechanical fish guidance systems or behavioral fish guidance systems, like the bubble curtain here in blue. And that's what this project is about, is trying to create a new fish guidance system. Something a little bit different, something innovative, something where we want to balance the cost of the implementation and design. So we want something cost-effective and that will be suitable also for different species. And this is how the Fishpath project appears. So at NINA, we've been working in this topic for some years, and we had some projects before this one where we also looked in fish passage and improving fish passage and also some of the more conventional fish guidance structures. And we had a workshop on fish guidance systems in 2018, where we, together with other researchers from other institutes and also industry here in Norway and environmental agency, we all gathered and we discussed like how we could improve that. And this was some of the ideas that we defined, like why not to try to use turbulence, because most of these fish passes and guidance structures, they're pretty much based on velocity. So we thought about, let's do something new. We knew that turbulence impact fish, so why not try that? So let me introduce the Fishpath project. So Fishpath aims for turbulent eddies to create paths for safe downstream migration for salmonids and yield past hydropower intake. This project was funded by the Research Council in Norway. It's a project at NINA, led by me and my colleague Torbjørn Forseth. It started in April 2021 and will end in 2026. And it has about 20 million kronas, more or less 2 million euros. We are many in the project, many partners from different research institutes. We have main partners NINA, ETH Zurich, NTNU, NORS, SINTEF. We also have international partners like the University of Michigan, DTU, and Karlstad University in Sweden. And we do have the industry partners, 8 industry partners, and the environmental agencies, and so Miljødirektoratet, NVE. And I would like to highlight that in this project, and something that's really nice and I really appreciate in this project, is that the industry partners, they not only fund part of the project, but they really actively participate in the project. They help us to develop this project. They come with ideas. They let us know what are the main needs of the industry, and they also come with their experience. And that So I think this is a very fascinating project in that regard. So, as I mentioned, the main goal of this project is to come up with an innovative guidance system and not so much these conventional ones with the trash racks. And what we're aiming for is like create a guidance structure with eddy-based behavior. So based on the behavior of the fish to the turbulent eddies. So here, for instance, an example of how we could use this system. We could guide the fish to a bypass, for instance. But we don't necessarily have to use this guidance structure at the intake. We can also put it in another part of the river so we can guide the fish to wherever we want. So that's the main principle. The project has 4 work packages. In the first work package, we'll try to have like a good knowledge and understanding of the link between the fish and these turbulent eddies. So how do fish react to the turbulent eddies? After, we'll try to design this guidance structure. So we'll go and test different designs, basically, and trying to develop. And we'll test for guidance efficiency. So we go from the lab to a bigger scale lab at Vattenfall, and we'll test like 1 or 2 of the most promising configurations. And later on, we bring one of those designs to the river, to the Mandal River in the south of Norway, and we'll test it for real. And then we'll also do some telemetry study to see and to evaluate the guidance efficiency of this new structure. And the last work package 4, aims to come up with some design guidelines for this guidance structure. So why turbulent eddies? So in nature, like fish are facing turbulence all the time. And from microscale to microscale, and we know that fish, they react to turbulence and they can be helped by turbulence as well to a certain regard. And there's been quite a lot of research on this topic. And because we know turbulence affect the fish swimming behavior, we thought, okay, let's try this, why not? So there are specific parameters of turbulence that are pertinent and important for fish, and that we know, because some of us have been working on this for some years, and we know that, for instance, intensity, periodicity, orientation, and scale of the eddies, they have an impact on fish. And those are some of the main variables that we're going to use in this project to develop this guidance structure. So let me talk a little bit of what we've been doing in the past 1.5 to 2 years that basically focus on this link between, or understanding the link between the fish and the eddies. So one of the things that we always kept in mind was like this relation with nature. And in nature, in a river, we have rocks. And what these rocks do when we think in a hydrodynamic part of the fluid, so they do create eddies. And it's a very chaotic system. It's a 3-dimensional chaotic system, very complex and very difficult to understand. But we do know that we can separate all of this and make it a little bit easier. And there's like 3 different types of eddies that are divided according to their orientation. We have the vertical eddies, the horizontal eddies, and stream eddies. Believe it or not, what you see there in that mess around the rock, that is what you have. And all these eddies, they will have a different impact on the fish as well. So they will affect the swimming performance and their sustainability on the flow. So it's a little bit of physics here, but it's a little bit like you have an object in a fluid, and then, of course, the forces that act on that object will have an impact on sustainability, and how the object is inside of the fluid. So this is what it is. So the fish is the object, and then we have the fluid around the fish and all the forces acting, and you will respond to that. So based on this idea of a rock and how things are developed, we construct what we call the single elements that is basically an hydrofoil to support, and then we test like different appendages that will create the different turbulent eddies that we want. So in this work package 1, what we did so far, we did some CFD modeling of the flow field for the different elements. And we already had 2 campaigns of live fish tests, one in spring 2022 and one in spring 2023 with the salmon smolt. And we are currently now also preparing the next experiments in the fall with eels. For the CFD modeling, as I said, we tested for different designs. So our colleagues from Sintef, they are also a partner in the project. They developed this part. And we did some ADV measurements, and then we combined it with literature, and this was what was used for the validation. So if you see it here, for instance, that's something, some image from the validation. I don't go through the details, but basically it was very positive because what we got from the CFD could really simulate the reality of what was tested in a lab. And here's the lab. So the lab is at ETH, at the Laboratory of Hydraulics, Hydrology, and Glaciology. It is a long flume where we did these live fish experiments. So as you see in the dark, can I use this right here to point? Okay, somewhere there. So first we have like this area, that's the acclimatation area where we put the fish. We let them there for some minutes so they can acclimate to the condition, the hydraulic condition, and then we let them to go through our arena, our test area. And here you can see like 2 elements, and those were the elements that I previously showed. And then we see what the fish are doing to the hydraulics that is created by those elements. So here's a picture of the flume where we did this. And this flume was the one that was used for the experiments in 2022 and now in 2023. And here's, see, at least we can see one video is working. Oh, sorry. Nope. Okay, now it's working. And here, for instance, you can see the videos from one of the tests. And what I would like to point is like, see what the fish is doing down here, is going up and down. And this is one of the response of the eddies that we are testing. We're testing like these horizontal eddies, and this is exactly what we're expecting. So we are very happy with the results that we're getting because the fish are cooperating. So good news. We also track the fish. And then this was basically what we got. So here, let me guide you through this. So we have the 2 elements here, one here and another one here. And the fish is coming from this side. I don't know if you are seeing here. So it's coming from the left. And then he avoids the first one, and he moves to the second one. And he avoids what is happening in the second one. So this gives us very good insights of the type of hydraulics that the fish like or don't like, and then we can play with that to develop our guidance structure. So it seems that fish can be guided by eddies somehow. This is like some of the results of the experiments run in 2022. So we test like different configurations, as I mentioned, and these 2, in the first one, in the first design, we got 75% of the fish. They were guided, meaning that they avoid the area with like high turbulence. So let me go back here. So yeah, so being guided is like enter in the flume and then pass the first element and continue and pass the second one. And not go, but, let's see, yeah, and not go to this area here. So basically most of them, they did this. And that's the idea, is that they follow the path like that we're going to create. And when we overlap where, for instance, the fish were, most of the fish were, with the hydraulics that was created, we can also get some interesting insights in terms of the preference, in terms of velocities, in terms of turbulence, in terms of eddy characteristics. I don't go through all of those parameters here because I don't have time, but that's pretty much the main idea. So like I said, We run some experiments with salmon in March 2023, and who you see here, like it's Kamal, the PhD student of this project, is based in ETH, and Joya, that was she's from Germany, and she was helping Kamal with this experiment as well, and she will soon, hopefully, will do a master's with us in this project as well. So this is a work in progress. We are now analyzing the results. But for what I know so far, it's looking very promising. So we are happy with it. If you'd like to know a little bit more and get more information about the project, you can find our webpage. And this project I would like also to highlight and mention is also affiliated to the Hydropower Center. So you also can find more information there. Yep. Thank you very much.